Okay, this question is from that review pack for our Unit 1 test on sequences, series, binomial theorem, and proof. And specifically, this is dealing with counting principles. So I just want to quickly go through it. So we've got 8 boys and 2 girls that sit on a bench. Determine the number of possible arrangements given that the girls do not sit together. Okay, so let me just what I like to do with these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so there are 10 seats on the bench. We have to fill, um, so if I've got 2 girls and then I've got 8 boys, I'm gonna 2, 3, 4, 5, 6, 7, 8 boys. Okay, so for the girls, first off, the total number of ways that anyone could sit together, because there's 10 total people, would be, so the total possible would just be 10 factorial, right? Now, if we say that they cannot sit together, well, let's just imagine if they did sit together. If the girls the easiest way of solving problems like this, a lot of times when we see the not, is we go to that counter positive, right? Where we're trying to do like almost like a proof by contradiction. So if I take the total possible and I subtract from it the number of ways that they sit together, I will have my answer to part A, okay? So that's what we're going to do. We just got to figure out how many ways they can sit together. So to do that, if they sit together, then we can kind of treat the 2 girls as a single entity. So now it is a block of 2 and 8 boys. So how many total are there? There's 9 total in that case. Instead of dealing with 10 individual people, we've got the 8 individual boys and the 1 group or 2 girls. So what that would turn out to be is, if we did that, it would be the 9 factorial would be the new arrangement, because now I'm dealing with 9 objects instead of 10, because I've grouped the 2 girls together. But inside those 9 objects, the girls, they could sit either on the left or right of each other. So we have to multiply that by 2 factorial, which is just 2. So what this is going to turn into is, for this first part, we do 10 factorial, take away 9 times 2 factorial, and that should give us our answer. I don't have my calculator open. Where is it? And it doesn't seem to want to open, so maybe I won't be showing you that. All right, but from there, we can move on, okay? So looking at this situation again, I'm just gonna do a quick, so now I'm gonna take that, and we've got our same 10 bench spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on those 10 bench spots, the deal is the girls can't sit on either end. So we don't have that restriction that they're a group anymore. The only thing that we have is that the girls can't sit on either end. So approaching this one maybe a little bit differently. So this has to be a boy, and this has to be a boy, okay? If I put a boy on this end, because there's only 8 of them, I have 8 that I can choose from. If I have one there, that leaves me only 7 left here. So that means that in this middle, this combination, I would only have, what, 8 people left? So 8 factorial. So for that next one, it's just going to turn into 8 times 8 factorial times 7 would be the number of ways that the girls could sit on the bench and they could not sit on the ends of the benches. Okay? And again, I'll solve that at the end with my calculator. All right, so now the girls are not on either end and they do not sit together. Okay? Not on either end and don't sit together. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, again, this has to be a boy. This has to be a boy. So we've got that 8 and 7 on there. And then inside here, we would have, what, there's 6 more boys left and 2 girls. Again, we can treat the girls as one group. So that means that there's one group and 6 boys. So that would be, there's 7 factorial ways for them to sit there, and this would be everyone's, the girls are together and we've got those 6 boys there. So if I did that, I would end up with, because I have a total of 8 spots, so not be together would give me 8 factorial, because there's 8 spots, minus 7 factorial. But remember, being together, I have to also, because there's 2 factorial ways that they could sit together. One could be on the left, the other on the right, and then swap it over. So I have to do times 2 factorial. So that would be, this would give me not together, and then we have to also multiply that by 7 and 8. Right. As I said, we're going to go back and I'm going to see if I can't do this on my calculator. Look at that, we're in radians. Awesome. All right, so if I go back to the top, I ended up with, sorry, come on. And my calculator is not working. I guess I'm just going to say, for sake of time, because this is not working, I'm just going to call it there. I hope that's helpful.